In this example, we're going to use the hide and cover technique, and the hide and cover is just another way of saying find the x and the y intercepts here to graph the following equation. So let's try to find the x-intercept, and for the x-intercept, it's going to be some value of x, comma 0. The value of y will be 0. So what we're going to do is we're going to look at this equation. We're going to ask ourselves, well, if y is 0, then 4 times 0 is 0, and that will go away. That term here will go away. So we'll be left with 3x is equal to 12, and that's where this hide and cover method kind of comes about. So we'll divide by 3 here, and we get x to be 4 when y is 0. It's very important that you realize that. For the y-intercept for this one, we'll try to do that down here. We're going to do the same thing, but this time the y-intercept is going to be 0, comma some value of y. So we're going to substitute 0 in here for x. 3 times 0 is 0. We're left with 4y is equal to 12. And then we'll divide by 4 here, and y will be 3. Well, y is 3 when x is 0. So the actual point we want to plot here, and if you're hearing a baby cry, don't worry, she is fine. In the background there, it is bedtime, and evidently she is not to sleep yet. So I sincerely apologize for the baby in the background if you can hear that. Anyways, for part B here, we're going to try the same thing, and this time we're going to, let's see here, we're going to solve for x here first, and so we'll just replace y with 0. Negative 2 times 0 is 0, and we're left with 3x is equal to 18. And I probably am getting off track here. I should have connected the old dots on this one. So let's do that before I forget. We'll divide by 3 then on the right. X is equal to 6. And we know that x is 6 when y was 0. That's what we did here. We said, hey, negative 2 times 0, so that's 0, and we're letting y be 0. Okay. So here's your 6, 0 right there. Now, if we let x be 0, we'll have negative 2y is equal to 18. We'll divide by negative 2, and unfortunately that gets us something that's off the graph. That would be a negative 9. So I think in this case what we're going to have to do is change this equation, negative 2y plus 3x is equal to 18, and what we will do is we will subtract 3x from each side. So we've got negative 2y is equal to negative 3x plus 18, divide by negative 2 everywhere, you get to every single term, and we get 3 over 2x minus 9. Well, we know that negative 9 here, and I'll move this over just a bit for you. We know that negative 9 is the y-intercept, but now we have some slope to help us out, and it's positive. So we could go down 3, left 2. That would still be a positive slope, down 3, left 2. This represents negative 3 divided by negative 2, which is still positive 3 over 2. So, and you can tell here if we went down 3, left 2, we'd be, you know, kind of in that area where that negative 9 is. You can extend the graph a little bit, but it's really a good idea to plot a few points that are actually on that coordinate plane.